Hello and welcome to today's webinar. As the title of this event suggests, today's topic will be our Siemens LPIT solution for medium voltage grids. In the next half hour, we would like to give you a little insight into some details and unbox our solution. Also, we want to discuss how this solution can provide benefits in the various areas of the distribution grid level. To begin, however, I'd like to ask you a quick question. Have you considered the use of low-power instrument transformers as a measurement technology in your medium voltage switchgear? And are you planning to implement it, or is this topic completely new to you? You will find the voting options on the right side of your screen. If you cannot see the field, you might have to leave the full screen mode. Our session will last approximately 30 minutes and will include a Q&A session in the end. Please note that since you cannot ask your questions directly while we are presenting, we invite you to type your questions during the presentation into the question box. Our colleague Yelitza Rojas will join the chat and follow your discussion. She is one of our promoters for Cyprotec protection devices. We will then address all questions after our talk in the Q&A session. Remember, you will have access to this recording also on demand just right after the session. My name is Lars Schulz, and I'm excited to be your host today. I am product manager for part of our Cyprotec Universal Relays. Fortunately, I am not alone here today, but have two very valued colleagues by my side. I'm also happy to welcome Bernd Schüpferling and Kerem Bayram from product management. Ben Kerem, please introduce yourself briefly to our audience.
Yeah, thanks. Yeah, a very warm welcome also from my side. My name is Bernd Schüpferling, and I'm the responsible product lifecycle manager for digitalization and secondary systems within our gas-isolated switchgear.
Lars, thank you for the introduction. A very warm welcome from my end as well to our audience today. My name is Kerem Bayram. I'm one of the product lifecycle managers for the medium voltage air-insulated switchgears of Siemens. And today, with my esteemed colleagues, we will be unveiling a new feature out of our portfolio together with you. On to you, Lars.
Thanks, Kerem. Thank you both. To start our discussion, I would like to start with a question regarding a very present topic, namely sustainability. Kerem, what do you think about the very ambitious goal of a fully decarbonized energy supply in Europe by 2050?
Nice question. Thank you. Thank you for giving me the speech about one of the most important topics of our time, Lars. The goal of fully decarbonizing Europe's energy supply by 2050 is a real hard target, but it's widely seen as necessary for mitigating the impacts of climate change. It certainly requires that each and every actor in this game work in synergy in the same direction. Steps should be taken to address a wide range of issues, and these steps should cover each phases in the life cycle of products and services. And as you'll agree, a significant part of such an act involves the massive installation of renewable energy sources. Do you all agree on this?
Yeah, definitely.
Okay.
Definitely.
However, there is a drawback. The drive toward electrification and decarbonization through increased use of renewables puts volatile in feed as well as bidirectional flows on the power grid. This emphasizes the importance of monitoring not only high voltage power grids, but also low voltage networks, both from the power generation side and the consumer side. Because the operators require better insights into their grid, better technologies resistant to such volatility is required. So with a similar approach, we are working on solutions to serve the future of our Earth. Our soon-to-be-released LPITs, both in air-insulated and gas-insulated switchgear, are a good measure supporting this idea. And Bernd, as far as I remember, you have a short video touching this topic briefly from the secondary distribution perspective in GIS.
I think we have it with us and can put it on the screen.
Nice.
Increasing number of renewable energy supplies requires additional current and voltage measuring in distribution grids. Siemens presents a smart and intelligent cable connection bushing. A capacitive divider for voltage and a Rogowski coil for current measurement provide an accuracy better than 0.5. Due to its compliance with the instrument transformer standards, several protection and indication devices can be connected to the SI bushing. SI bushing, the sustainable, smart, and intelligent solution in future-proven ring main units for energy supply balancing and e-car smart charging integration.
That's a very interesting video, Ben. Thanks. Could you tell me a little bit more about the actual design of conventional voltage and current transformers and why it would be necessary to replace them, for example, with LPIT technology?
Sure, Lars. We have to differentiate here a little bit between the AIS and the GIS switchgear. As the designs are different, in AIS switchgear, we have so-called block-type cast resin inductive transformers in use to measure in an accurate way voltage and current, and they are directly installed in the main circuit of the switchgear. Their design is material intensive, and a lot of copper, iron, and epoxy is used to manufacture them due to customer requirements. In GIS switchgear, inductive current transformers in a ring core design are used to be installed outside the enclosure around the cable connection or at the cables. As they are not directly located at high voltage potential, the requirements on the insulation are not the same as in the AIS switchgear. Conventional inductive voltage transformers in GIS have a metal encapsulated or a metallized design. Especially for higher voltage levels, they are very heavy and material intensive. As a contribution on the sustainability of medium voltage switchgear, alternatives in a low power design reduce the usage of raw materials like iron, copper, and epoxy. Besides that, the LPITs offer further opportunities to reduce the dimension of the switchgear itself, especially for our compact GIS ringmain units.
And how do these LPITs look like?
Yeah, this depends again on whether we are looking at AIS or GIS switchgear, and whether we are talking about integrated or externally connected sensors. Integrated LPITs could look like the SI bushing, which we can see here, and we have it live in the studio. This is our new GIS smart and intelligent cable connection bushing with current and voltage measuring. Furthermore, the design depends also on the used technology of LPITs. Today, I'm only focusing on the used technologies in our integrated AIS and GIS switchgear. For current measuring, we are using the Rogowski coil, which is an air coil without a ferromagnetic core. In both GIS and AIS switchgear, it is integrated in a cast resin bushing of our switchgear around the primary current path. As the voltage that is induced in the Rogowski coil is proportional to the derivative of the current, an electronic integrator is required to provide an output signal that is proportional to the current. In our design, the integration is part of the connected protection or indication device. For voltage measuring, we decided to use a resistive voltage divider in AIS and use the available smaller space in the GIS design, a capacitive voltage divider. As the integration of the output of the Rogowski coil is done by the connected electronic protection or indication device, and as both used voltage divider technologies are passive systems, we have no active electronic in the primary path, and therefore no reduction of the expected lifetime of the switchgear itself. The outputs of the three used LPIT technologies are providing signals defined in the IEC 61869, which is the applicable international standard for instrument transformers. The IEC standardized pin assignment of the RJ45 connector at the connection cable will ensure that there will be a large number of short circuit indicator as well as measuring and protection devices being compatible with our integrated LPIT solution.
Thanks, Bernd. That sounds really interesting. Kerem, as I understood it now, those LPITs contribute to sustainability because they are using less resources for manufacturing because of their small footprint. Is there any other advantage related to sustainability when you integrate those LPITs into the switchgear?
Absolutely, yes. But let me have a short add-on on the topic of resource use.
Sure.
So the level of savings in the resource use has a direct relation on how you integrate and locate the sensors in your application. This is clear. You may either use standalone LPITs as separate components, or you can simply locate these sensors, small footprint sensors, into one of your existing components already available in your switchgear. And of course, the second one has the highest impact on resource use. And this is how we do in AES exactly. So we locate the sensors into the existing bushings of NX Air family products, and thereby maximize the savings from the resource use. And coming back to your question about the sustainability in the operating phase, by eliminating the conventional block type transformers, ohmic resistance related power losses are being reduced. What else? Power dissipation due to secondary windings and iron cores are being fully eliminated. Additionally, losses on the wiring harnesses are being dramatically reduced. And last but not least, even the losses due to required relay burden are being reduced down. So at the end of the day, LPITs support our switchgear to be much more sustainable, not only in the manufacturing phase, but also in the use phase, operating phase of it. They help to reduce energy consumption, and accordingly related CO2 emissions are being reduced. Operating costs are being reduced on customers' end, and this has a direct effect, of course, on the operational expenditures of our customers. So, Lars, we have briefly discussed about the basics of LPITs, but of course, it's clear that this approach requires a compatible protection device. So how will you be supporting us on that topic?
I was sort of waiting for this question, Kerem, because I'm really happy to also announce the newest member of our Ciprotec 5 family, the 7SY82. It will be a universal device with measurement inputs for low power instrument transformers.
As expected, your usual support is always there. But from the very beginning, you got my attention. You used the wording universal device. So this I can pull into each and every direction. And I guess it's the same with our audience. So, and I would assume that you will be touching each and every aspect about this, about being universal. But let's park this topic now and focus on the same sustainability topic. So does it also mean that it has an addition on being more sustainable in the distribution grid?
That's true, because over the last years, we introduced several or a new product line into our Ciprotec 5 platform, namely the universal devices that offer the user a maximum amount of flexibility. Because if you imagine you have a certain asset that you want to protect, for example, a motor, you would need a protection device. If now, for whatever reason, this asset is changing and replaced by a cable line in the same bay, you would need to change your protection device because you need different functions. Then you would have to purchase a new protection device. This would have to be produced. Materials are used for this. And you have to dispose the old device, meaning you are creating electrical waste. The Ciprotec Universal Relay, like also the 7SY, can be simply adapted and configured with new protection functions. Like this, electrical waste can be avoided and resources can be reserved since you don't have to buy a new device and just reuse the old one. So the universal device is not only contributing to sustainability, but is also offering a lot of flexibility to the user, which is the topic I would like to stick with for a moment. The flexibility topic. Do those LPIT sensors also offer further advantages in case of flexibility or even reliability?
Yes, there's a big set of advantages coming along with LPITs. Sustainability, reliability, flexibility, and safety are the four most important ones from my perspective. So from the reliability perspective, from the technical background, sensors are immune to grid disturbances like ferroresonance phenomena. So they remain linear over the whole measuring range, even up to the rated short circuit fault currents. And the other aspect related to being reliable, conventionals involve many cables and terminals, and it is inherently prone to human error. This is totally the opposite with LPIT. So here we are talking of a single wire carrying both current and voltage signals with an RJ45 plug at the end, and this plug is directly being connected to the relay. Therefore, this decreases the risk of malfunction. Just imagine the Ethernet cable entering to our router, to the routers at our homes. Don't you think this is almost error-free?
True.
That's right. And from the flexibility perspective, due to a single design with a wide dynamic range covering the whole switchgear portfolio requirements, it enables us and it gives us the flexibility to change the parameters even during the operating phase of the switchgear. The best example is a change requirement on the feeder current. This can easily be done simply by changing some parameters on the relay side, even during the operating phase at our customer sites after the delivery.
Yeah.
And Lars, what's your plan to keep up with all these flexibility which we have in JS? Will you allow us to exploit all these benefits when we use your upcoming 7SY82 relay?
That's a very good question, Kerem. Thanks for that. To tackle this topic, we designed and developed a new hardware especially for the connection of LPIT sensors. And the measuring inputs of this hardware are also enabling this extremely wide dynamic range. In concrete terms, this means that you can measure secondary values very precisely over a larger range than it was previously possible. It also offers other benefits, because let me come back to the advantage of the Rogowski coil. As you mentioned, because of the linear behavior over a large range, it would be possible to change the primary nominal current even during operation. That's possible because even after increasing this value, you still don't have to worry about reaching saturation with those sensors. And that's a huge advantage compared to conventional current and voltage transformers.
That's great.
Yeah, there's one more question from my side. As we mentioned earlier, there is a variety of different LPIT technologies available. How is the protection device 7SY82, which we have in front of us, dealing with this diversity of manufacturers and measurement principles?
Thanks, Bernd. There are two aspects that play an important role here. The first thing is the measured dynamic range of the measurement inputs. This range is designed in a way so that the complete nominal current range, for example, for your SI bushing or the AIS sensor, are fully supported. Another aspect of the connection is the design of the connection to the device. You mentioned earlier the standard IC 61869. This was created in an attempt to standardize this LPIT technology regarding the application of LPIT. And this standard also defines, for example, the pin assignment for the RG45 connectors. And during the design of our device, we kept it compliant to the standard. Doing this will enable the device to work with different sensors from various manufacturers as long as certain preconditions are met. So as you can see, what is special about the device, it's its versatility on different levels, the measuring inputs and the protection functionality.
Yeah, I see. So coming back to the differences between conventional and non-conventional CTs and VTs, the main difference between both technologies is that the LPITs for current and voltage measuring are transferring primary values into a small secondary voltage. So Lars, how is that affecting the operational stuff and the overall safety of those LPITs?
So as you both most likely know, one of the major hazards during commissioning and installing a switchgear is the handling of the secondary circuits of the conventional instrument transformers. Correct wiring and handling must always be ensured in order to avoid accidents. And as you mentioned, the special property of those LPITs is the low output power and the secondary voltages, because these range only from a few millivolts to several volts. Thus, the danger for the execution personnel is significantly lower compared to conventional transducers. And because we use RJ45 connectors in our solution for connecting the sensors to the device, we also minimize wiring errors. As Kara mentioned, it's basically just plug and play, which is making installing and commissioning of those devices during project execution even easier. This would also lead us to benefits regarding project execution. But how do LPITs change the manufacturing and installation of the medium voltage switchgears?
Yeah, thanks, Lars, for this very important question. So when we have a look on the actual configuration and order process of conventional CTs and VTs, more or less all of the CTs are project specific due to different customer requirements. VTs are a little bit more standardized, but we also see here a big variety of different ratings. As a consequence, we have to order the conventional instrument transformers project specific, which means individual production of low quantities at our sub-supplier instead of mass production of a standardized design. Our integrated LPIT are designed as a one-fits-all, what means that customers have no choice for different ratings, and we could use a standardized design for almost all the protection and measuring purposes. Billing metering is the only one exception where we have actually no regulation that the LPITs could be used. But there are already established working groups and local associations to find also here a suitable solution with our LPITs.
So as I understand it, those LPIT solutions you just presented are more for greenfield applications. Are there any options to retrofit an existing switchgear?
Yeah, yes, there are. For brownfield applications, we recommend to use the LPITs we have already delivered in thousands of pieces, which can be installed on existing switchgears. LPITs for current measuring a split core design can be installed very easily around existing cables. Voltage measuring can be retrofitted on GIS switchgear with outer cone cable T-plugs, while installing a voltage sensor in the backside of the cable T-plug instead of the existing basic insulating plug. The only challenge we faced out here is to know exactly which T-plug is installed, as the backside of them are not standardized and have different dimensions, which require therefore different sensor types.
So Bernd, what's your suggestion here? Which of them shall be used for greenfield as well as for brownfield applications?
Yeah, Karim, interesting question also. So we trust on the delivered external LPIT solution, as we got no feedback from our customers that they have been any functional problems with them. So I recommend them also as a perfect brownfield application in the future. But for greenfield application, I recommend to order in the future already the switchgear with the internal bushing solution, which we have here on the table again. As then the switchgear is already prepared for any further measurement functions.
Bernd, thanks. Now I guess the basics about LPITs are clear to our audience today. But Lars, so sorry to insist on the same topic, but I would like to come back to this universal device naming. So up until now, you talked about sustainability aspects, safety aspects, and somehow flexibility aspects of it. All understood. But what about different types of protection requirements? Is it possible to tackle all these as well with this universal device?
Karen, that's a very valid question. This question can be answered quite easy, actually, as the 7SY82 will also be able to support all other functionalities available to the other known Cyprotec 5 devices for medium voltage applications. Like our other universal protection relays we introduced in the past years, there will be no device type preloaded into the device. The user can choose the functions freely from the whole Cyprotec 5 library. Like in every other Cyprotec 5 device, this can be done by using function points. What's special about this universal approach now is that the flexibility to select and change the functionality is at any time during the project. Because the function points can now be ordered by the user and installed by the user itself, you could basically also split the purchasing process from the engineering of the project. If you can commit on the hardware you want to use, the functionality can be changed, for example, right even before commissioning. Working in such a way helps you to reduce the whole project time because you can work on processes in parallel. In this case, maybe you can already start the engineering of the project even though the devices are not yet purchased. So the device is not only applicable for every use case, but like the LPITs offer also benefits to your project. And with that, I would like to conclude our talk. Thanks to Bernd and Kerem for the interesting insights and important questions. As I mentioned in the beginning, you still have the chance to ask questions in the chat. We will now take a look what kind of questions you asked during our discussion. Therefore, I would like to ask you, Jelitza, are there any questions in the chat?
Sorry, no. Hi in the studio. Yes, we have many questions in the chat. I am trying to answer them, but I would like to come to you because there are many questions regarding accuracy. So maybe you can talk a little bit about that. So I guess it's one of the main questions or topics that our listeners are right now trying to find out.
Understood. Should I go maybe first from a protection perspective and then you can take it up?
Why not?
So from the perspective of the protection device, we are aiming for the same accuracy as we have with our conventional devices. So if you know your CPROTEC 5 devices for medium voltage application, the accuracy is planned to be the same as well here for our LPIT solution.
And having a look on the integrated LPIT, so what means on the Rogowski coil, on the capacitive and on the resistive divider. So we have tested them to the IEC 61869 standard in official labs with an accuracy class of 0.5. So we were often asked also if we can reach the 0.2, which is required at the end of the day also for the billing metering.
Right.
So this is something, you need some challenges also in the future. So therefore, I would say we have still this 0.5 and the 0.2, maybe it's a target for the future.
Yeah, whatever you told remains the same with AS. Our first release will be 0.5, and we will be looking for possibilities for 0.2.
Nice. So maybe we then take a look at some other questions in the chat. So I see one question here from AL asking, how do you test relay functions when it seems like you cannot use Omicron secondary injection? Good question, because this is one thing that would mainly change for those devices, but actually, especially from Omicron, there is a solution where you can reuse your existing CMCs, for example, and have a little addition to it in order to test our 7SY82. So there will be options available for you to also test the device on the secondary side.
That's right. As an example, the existing CPC100 from Omicron, which we use for conventional, simply by adding a Rogowski card and purchasing an adapter wiring in between, this can be used for the same purpose with LPITs.
So also do the primary testing.
Definitely.
Nice. That's cool. Maybe we don't.
I think this is also an interesting question to the interoperability. So, first of all, we have a Siemens session today. So our target is to sell Siemens products. But however, we know that many customers are also interested on the so interoperability. So this is also something which is on our focus. What means we have international standard interfaces from the IEC 61869. And therefore, it is theoretically possible in the future also to have a sensor from a foreign brand together with the 7SY and vice versa, our sensors together with other protection relays. So we will have some interoperability tests also. In this question, there are also named special brands and relay types. So this will be done also in the future, and we will have in our catalogs also the reference which devices can be used with the sensors and vice versa also.
Maybe a short answer to this could be, if both parties, relay and the LPIT, are both IC compliant, theoretically this is yes.
Maybe here's a question to the GB, the first one.
Coil, yeah. I think this is related to the so-called crosstalk. That means you have an interference from one phase in the switchgear to the other while using the Rogowski coil. Yeah, at the moment, we have tested our solution, especially the C-bushing, in the ATJH, which is the smallest, which is our switchgear with the smallest dimensions in between the phases. So we are talking about 95 millimeters there. And also there we have tested that there are no interferences, so no crosstalk from one phase to the other. In any way, we have the possibility with some correction factors also in the so-called JSON file, which we provide with our sensors here, and they will be integrated in the protection relay. We also have some correction factors concerning temperature ranges. And also for this crosstalk, there is a possibility to put them as correction factors into the IED, which will be connected to our sensor.
And this is only one out of an extensive set of type tests we conduct, both in AS and GS.
Yeah. Okay, this question.
Maybe we take a look, because it's somehow similar to what we already answered. Maybe we take a look at the next slide. The next questions.
Yeah, interchangeability is question, the same.
There's also protection functions.
Testing functions you have already on.
So maybe one question here, can the 7SY82 be connected to revenue meters class 0.2? I mean, this is somehow coming back to the topic Bernd was just telling. There are like two sides of this story. One is whether you have a low power instrument transformer, a sensor that is, let's say, valid to use it for billing metering measurements. This is the one topic. And the other one is, of course, if it's compliant to the standard and like fits to our solution, then yes, it's possible to connect it. But this maybe has to be checked, and there's no like general answer for this.
Just an info. As of today, there are even some national standards available for revenue metering with LPITs. But unfortunately, there is no international one.
Yeah, but I think the question is more related to, because with the LPIT technology, you can only connect one device to one sensor. In my opinion, the question is more related to the process bus topic, that there will be a connection from the IED, from the protection relay, towards a second device. And therefore to use here the billing metering. So you're more the experts than me. What about the process bus story? Is this also something which is on the roadmap then for the future?
This is also a question because, as some of you might already know, that a little bit familiar with the portfolio, that our medium voltage devices, the non-modular ones, don't have process bus yet, but of course we're also planning to implement it quite soon and are working on it to also provide this for LPIT solutions or for the 7SY82 to also offer more functionality. For example, also a transformer differential protection, which is not possible from the start.
Okay.
This is also covering then maybe the question again from the here already some people looked at the document and know that the relay has, as mentioned, universal device, a lot of protection functions for line and motor, for example. And the question is, will transformer differential protection be added to the device? And this is like currently not possible because the length to the sensor by using an RJ45 cable is limited to 10 meters. This is for a transformer differential application difficult. Therefore, we need the process bus in order to also receive measurement values from another device. And then we will also add the transformer differential protection also to our device.
And also an LPIT integration into Protect 4 is questioned.
This will most likely not be done, as we are all putting all our efforts to grow and to increase the functionality for Protect 5. So probably the new LPITs, there will be no solution for Protect 4, unfortunately.
So universal going to be the new breed.
Yeah.
Yeah, that's also one important question. What is the benefit of integrating the LPCT inside the bushing rather than putting a standard LPCT around the bushing? Yeah, this question is right. So there is no big difference in case of the LPCT, because if it's in or around, so it's also from maintenance and also from manufacturing and also from the purposes of installing, commissioning, it's not a very big difference. Though the focus is more on the integrated voltage divider, because this, as I said further, we have the problem that the cable T-plugs, which are in use normally on the switch gears, don't have a standardized backside of the T-plug. And therefore, this logistic challenge to find in every time on site the right plug for the right sensor or vice versa, this is more the topic we focused, and therefore we integrated it in the bushing. Clear, LPCD could also be mounted around, but if everything is already inside, coming out of the factory, so you have no topic with cabling, with everything on site during the commissioning process, which makes it much easier if everything already is integrated in the switchgear coming out of the factory.
And one additional reason is, as mentioned earlier, is the reduction of reuse of resources.
Right.
That's another one.
So there are more questions related to the LPCTs. Is there something?
Ratio and accuracy class has been touched. Same.
Now maybe to the ratio. So accuracy class, it's clear. We said 0.5, and we are looking forward to targeting the 0.2. Concerning the ratings, so we are following for the capacitive divider, the 10,000 to 1 mentioned in the IEC standard, and for the Rogowski coil we have, and this is a little bit different between if we are focusing on the ring main units, or if we later on have a look also on switch gears with high primary currents. But at the end we will start in the ring main units with 50 amps to 22.5 millivolt in the Rogowski coil.
In AS, it's 80 amps to 22.5 millivolts, and for voltage sensing, it's 17.5 kV to 3 volts.
So, but as we said earlier, both are following the values in the IEC standard.
That's right.
And therefore, the interoperability can easily be done. Interesting question, the product of us. When can an NX Plus C Blue be delivered with LPIT? So we are unboxing today the solutions for the LPIT and the protection relays. So the official sales release is expected for summer 23. So that means as soon as we have the sales release, they also can be used. So the integrated version with the SI bushing also in the NX Plus C 24, as well as in all of our products with the outer cone connection.
Size of the bushing mounted LPIT questioned. I guess this is more for AAS. So are the footprint of the bushing as we use in conventionals remains the same? We simply integrate the sensors into the same volume of the bushing.
Yeah, I think then we are reaching the end of the question session here, because I think this is don't go any further.
There is an abbreviation ACB. This we need to park, I guess, and answer later on.
Yeah, but yeah, I think because all questions we can't answer today, we are taking also, of course, up and sending them afterwards around. And this brings us sort of to the end of our session. You will, of course, get access to the recording right after the end of the session. And we will also send out the link to the recording for everyone who could not join today. And we hope that we could also give you an overview over the many aspects where LPIT technology can improve current technologies and provide benefit for the users. We would be glad to welcome you very soon to another webinar. Until then, I have to say thank you to Kerem. Thanks to Bernd. Thanks to Jelica.
You're welcome.
Stay safe and enjoy the rest of your day.
Thank you for your time.
Thank
See
you.
you next time.
Bye-bye.
Bye-bye.
Bye.